Question 19. 5 wavelengths are generated every zero point 0.1 second in a tank of water. What's the speed of the wave if the wavelength of the surface wave is 1.2 centimeter? Now this is a trick question. You might think that this is the period of the wave, but remember that the definition for period is how much time it takes to make one cycle or one wave. Here we can see that 5 wavelengths or 5 waves are generated every 0.1 second. That's like saying I need 5 seconds to print 5 papers. You can figure out that each paper needs 1 second to be printed. This is the same situation. I need 0.1 second to create 5 waves. So that means each wave can be created over 0.1 divided by 5 waves, 0.02 seconds. So that means each 0.02 seconds we generate one wave. Let me explain this in another way. So here we have 5 waves. 1, 2, 3, 4, 5. And these 5 waves take 0.1 seconds to be created. How much time does it take to create one wave? We will divide the total time to make 5 waves over the number of waves to get the time it takes to create one wave. So 0.1 divided by 5, it gives you 0.02 seconds. So this wave is created during the first 0.02 seconds, plus 0.2, that gives an 0.04, plus 0.2, that gives an 0.06. This is the third wave. Plus 0.02, it gives you 0.08. This is the fourth wave. The fifth wave, you add 0.02 to 0.08 and it gives you an 0.1. So you can see that each wave takes an 0.02 seconds to be created. So this is the period, the time it takes to create one wave or one wavelength is called a period. So T is equal to 0.02 seconds. Also you can see that given in the question is the wavelength. Let's read the question again and figure out how much is that wavelength. What is the speed of the wave if the wavelength of the surface wave is 1.2 centimeters? So you can see that the wavelength is given directly to be 1.20 centimeters. Now you might have noticed a problem here. The problem is that we have the wavelength in centimeter, and remember that we always deal with base units so that we get the base quantities like hertz, meters, seconds, and so on. So if he wants me to find the speed, which has a base unit of meters per second, we need to turn the centimeters to meters. In order to do that, we need to divide over 100. 1.20 divided by 100 gives you an 0.12 meters. So I have a wavelength, I have the period, and he wants me in the question to find the speed of the wave. Now if I want to use a triangle, V lambda f, you can see that to find the speed, I need to multiply lambda and f. So the speed of the wave is equal to lambda multiplied by the frequency. But unfortunately, I don't have the frequency in the known list, though I do have the period, however. That rings another bell. I know an equation that will enable me to find the frequency from the period. the frequency is equal to the reciprocal of the period, which equals to 1 over the period as given in the knowns is 0.02. So the frequency is 50 hertz. Now that I know the frequency, I can substitute it with the wavelength to find the velocity. So you can see that sometimes we need to cook one of the ingredients on the side and then incorporate it in the original recipe to find the original unknown. Lambda is 0.012 and the frequency that we just found to be 50 hertz. So 50 multiplied by 0.012 is 0.6 meters per second. So this is the speed.